All right, should be recording now. There we go, perfect. All right, I'm gonna share my screen. It's everything. Hopefully I don't have any embarrassing notifications pop up, but here we go. So for most of our environments, we require builders. We use these for all sorts of stuff. So this is all driven primarily from Azure DevOps. This is our CI/CD platform at Veradigm. Most of y'all on the call are probably familiar with it. We do a lot with it. The stuff that Sai and I, which you'll hear Team Cyanide a lot, that's just Sai and myself, the cloud platform folks, focus on is maintaining this so it all works and it all seems like we're not doing anything and the platform just always works perfectly. Like that's our goal, is it's intuitive. So one of the things that we're focused on is how our CI/CD jobs are run. We have used an auto scale group on the Azure side to drive most of the jobs. Like that's the Ubuntu 1604 and one of the Windows pools that you use for general compute to just drive your automation. But over on the AWS side, we've been kind of lagging. In context, the autoscale stuff that Sai has built on Azure rebuilds every day, every week. It's pretty frequent. So if there's any artifacts left over from jobs, they're not there very long, which minimizes our surface area for attack or for like a malicious job to be submitted that uploads the whole disk drive and gathers all the secure artifacts. However, on the AWS side, the stuff that I have mostly built, it's been static EC2 hosts. And I think I probably even have a couple that are still hanging around that I need to delete. Nick is going to get on me because these hosts don't do anything and they're not being patched very well, I don't think. And I think they're called, yeah, ADO Builder. You can see that right there. So this is just a static T2 micro host that has a little implant on it that registers it as a builder with Azure DevOps. And that's it. You know, there's no other real customization we do on these. I think I installed Git with Yum, and that's it. Otherwise, they're just a static host that's always sitting around. They're long-lived in terms of like months or years long-lived. So if anyone runs a job that downloads secure variables or passwords or anything that is sensitive and stores it on the disk, that might still be around later, months later, for a malicious job to gather up. We've mitigated that in some of the pipelines with specific tasks that like delete the working directory, but that's not something that's given to us for free in Azure DevOps. So it's something that we worry about. There's also other concerns like we spun up all these hosts and now someone needs to patch them. So we typically notify sysops like, hey, you have a new host, please patch this thing. And they do, but it's just extra work for them and extra patching and extra maintenance in case these break. We go and troubleshoot them one by one. Like maybe someone added a step in their pipeline to install a new version of something and it broke the builder or it broke somebody else's job. Like there's a lot of things that can go wrong with this static builder model. Not to mention, we just want to get away from servers, period, even if everything else worked perfectly. So what we decided to do a little while ago is explore Docker, explore explore dynamic instances that are both rebuilt frequently using the Docker language and Docker tooling and populated into like a container repo, and then also redeployed very frequently. And the model that we like the best so far is where hosts will spin up a Docker host and register as a builder, and then run one job, only one job ever, and then die. And then we have some automation that's sort of monitoring the fleet of builders, the cluster of builders, and it sees that host went down and it spins up a new one. And the huge benefit of this is there is no longer a concept of artifacts left over because the builder's literally deleted when your job is done. And also that there is no risk of cross-contamination in terms of like you require a specific version of .NET. So you put an upgrade in your pipeline and it ruins the thing for everybody else. You can do whatever you want in your pipelines because we're very secure in this Docker style model because it'll just get deleted afterwards. So do whatever you want. So that's our model. There's also kind of a democratization impulse where these builders were like, I think Sai understood the auto scale and I understood the EC2 instances, but like nobody else really did. And if you needed a specific something installed, you kind of had to talk to Sai or you had to talk to me and have us go do it. And that works. But as we scale out horizontally, that works less and less, right? Like if Sai's at lunch or I'm at lunch and you need to do something, well, you just have to wait. Too bad. So we want to get around that. So let's, if you're not familiar with Docker, that's totally fine. I'll define my terms as I go, but let's start at the build process, which is totally different from the run process. They're totally divorced. So over here, we have a repo in the TechOps project called OS Images. And if you just hit the drop down, it's the same place you find your Terraform repo. It's just called OS Images. And we have a couple of folders like pipelines and Practice Fusion and Viridian, and you can see that there are things here inside them. And this is a Viridian, it's a DevOps agent, it's Linux. And note that like in the namespace here, we're noting like this is owned by the Viridian team, this is a DevOps agent, this is Linux. That's all really heavy for like, we're only building builders today. But in the future, we will be building lots of stuff. Our vision for the world is that if any app team needs something that we can't provide in our general pool of compute on the Azure side or in terms of our Terraform executors on the AWS side, they can check in a Docker file and we can help them with building, deploying, monitoring, managing, patching. We can do all the rest of it. And all they would really need to do is provide, you know, that flat text file and maintain it. So that's the vision for the world in the future. But let's start with how we build the AWS builders here. So it's Ubuntu 2004. That's also a big change. We were using Amazon Linux 2, I think, on the AWS side, and Ubuntu 1604, which is now deprecated on the Azure side. And so we decided, like, let's get it upgraded. We might as well change this around. So inside here, we have a Docker file, which has all sorts of stuff. And this will look very scary if you've never seen Docker before, but really it is a ordered list of stuff to do. So first, download the image from the Docker Hub, Ubuntu with tag 2004. You can kind of guess what that means. And then set an argument, set an environment, run a command. It's really simple. It's very much like Bash or any other simple scripting language. And you can just see sometimes the thing that you'll see that makes it Docker is there's these little backslashes, which in Linux terminology means continue even though there's a return, even though there's another line. And it's just to make it easier to read for the human beings that have to maintain these files. But it just goes through this list and builds the thing. One of the very last things it does, because this is a static image, it's like building a virtual machine or using Packer to generate an image, is copies this start file, start.sh. So copy it and chmod it, which means make it executable, and then start an entry point. Entry point is just a flag that says whoever launches this in the future, the first thing you need to do is run that bash script. So we have that stored in here. It's also just a flat text bash file, just like Linux command line. And this is the registration logic. So when the Docker thing is booted, it runs this script. This script receives some environmental variables like the URL for where our Azure stuff is and the token file, which is like how do you authenticate and prove that you're allowed to register and run jobs, and registers into a pool and starts being able to take jobs. Something cool about this is Docker runs on your computer too. So I have Docker running on my host. And so I can both build this Docker file and run this Docker file locally. I don't have that prepped, but I could. I have just a couple of commands. You can run Docker and it can actually spin up and register in a pool and you can make sure that it works. However, most of the time you wouldn't do that. A, because it takes a little bit longer, and B, your kernel has to be the same. So I'm on a Mac, I have a Linux kernel, so I'd be able to do this Linux builder. But when I want to work on Windows, I can't build it. I would need to have like a virtual machine that would then do, and you know, when you're virtualizing virtualized environments, it gets to be very slow and inefficient. So what we do instead is once this file is checked in, this is just going to sound very similar to Terraform if you've ever worked with that, is we have one pipeline per type of Docker file that we're going to build. And here's Azure DevOps, Viridian Builders, Ubuntu 2004. You can see some GitHub in there. That's early days, but Team Cyanide is working on it. And this is going to look very much like Terraform stuff. there's a variables block at the top, and we say, where's the Docker file at? Where's the folder location? What image tag do you want to use when you build the Docker? Which hosted pool are we going to run it on? Which ACR, which Azure Container Registry repo, Style, correct me if I get it wrong, are we going to push it to? Here's some AKS stuff, because Sai has deployed all of his with Kubernetes, which is so cool, and I don't understand it all yet, but I'm gonna one day. And then here's the AWS ECR, the Elastic one, which is the AWS's terminology for their stuff, and the name of the repo that we're going to push to. So all of this, just like in Terraform, is a variable at the top. And if you, we have a couple of cool things that we do in addition to Terraform that's new and that's sort of cool and shiny, and we can show it off. So first of all, when we check in code down here, it checks out the repo, it builds the image, it gives you a thumbs up or thumbs down that like the Docker stuff that you've submitted is valid or not. That takes a while. It's not as like Terraform takes less than 10 minutes. These can sometimes take an hour or 15 minutes or 20 minutes. It takes a while to test, but it's still valid because we use these images in a lot of places. So we want to expand testing in the future. And then once you merge it in, get some peer approvals and stuff, we do more stuff. Like we build the image, we push it to the ECR. Since this is public and the ACR is protected by a permit list of IPs, we log into the ACR and we add our IP of our builder. You can see some cool curl stuff, reaching out to Amazon and checking our IP, and then pushing to the ACR. And I'm going pretty quick. Please ask questions, but note this cool thing. We're building one image and we're pushing it to both clouds. We're literally pushing the exact same identical builder image to Azure as in AWS. That has a ton of benefits in terms of just operations, mostly for Sai and myself, but also for you all. If any of you all work cross-cloud and you write a script or you write some Terraform that works in one place, you should be able to just pick up your compute job and put it in the other cloud and it should still work, because it's literally the same image. And it might be running with Kubernetes versus ECS, that there's the Elastic stuff, but it's still the same image and it should still be able to run your jobs. So cool
questions,
stuff.
Kyler?
Yes, go for it.
I have a lot of questions, so I'll try not to derail everything. Yeah. All right, so you have the GitHub builder in there as well as the Azure DevOps builders. Mm-hmm. Is that I'm assuming this is a prototype, or is this actually in place?
I've spent like 16 hours over the last 2 days trying to get it in place, and it just deployed and it's not quite working, but I think I know why. So we're almost there to having builders deployed. And I think Sai has in parallel built something in. Yeah, go ahead, Sai.
Actually, it is working. So this is the same process that we are right now using for the dub project, Mike. And their runners right now are based on ECS ephemeral builds, like they do the job and they kind of terminate themselves. We register the agents both on Azure AKS for the centralized runners for GitHub, and we have dedicated pools for any organization in GitHub that needs to run dedicated jobs. But both of them work.
Okay. And then how does this tie in with GitHub Actions? Like, how is this something that GitHub Actions would call, or is this something that is like a separate use case for GitHub Actions?
It's very similar to how we do it in Azure DevOps. So if you click on the last one, Tyler.
Yeah, you have the host registered. Yeah, let's go find it.
Yeah. So if you on this one, in the actions, if you click on the repo, down runners. Yeah, so they actually register under the default the group, and they get tags called self-hosted and Linux and so on, and we're going to add some more custom tags. And in the action definition, what we say is, instead of just giving it like use a public host, we say use self-hosted host. And it picks up the active agent in this pool and runs on it. We can actually have a combination of Ubuntu or the other OS flavors as well, but we just need to tag them, and based on the tag, the actions pull up and run the job on the respective agent. Like suppose I have a Windows tag.
like how Exchange manages mail, like Outlook manages mail, like it can only exist in one folder. That's how our pools work today in terms of compute. When you register a builder, you put it in a pool, and that's the only place it lives. With these, you assign it n number of labels. So it could be, you can see there's already 3, self-hosted Linux, x64. You can assign more manually, or when it registers using the run.sh, it can add 50 more tags for like the account it's in or the types of compute jobs it should pick up. And those are sort of compiled, and you can target your GitHub Actions for those specific labels, any combination of labels.
Got it. Okay, and so the ones you've created here, they're being used for the www deployment, and then conceivably we would use like PF.
Yes. So for the PF also, we'll have their own agents, and that will be within their own account in AWS.
It's not registered yet, but that's the thing I'm working on. Is we're going to put a general compute pool in Titanium, and I'm also building a module, so we should be able to deploy to Gold and Silver if we want as well.
All right. Sorry, my headset just died in the middle of that question. Okay. I had one other thing I was going to ask. Oh, so you mentioned maybe a couple of things. So you mentioned that the Azure side is using Kubernetes and this side is using Docker. The AWS side is using Docker. What's the, yeah.
AWS is ECS, the Elastic Container Service, and it's kind of a proprietary Amazon thing that can run containers. Yeah.
Yeah. Okay. All right. And what was the reasoning behind? Well, I guess you're just using the Amazon service. Okay.
Yeah.
On Azure side, actually. Sorry, go ahead.
No, it was simple enough to do what we need. And I think Sai does additional cool stuff. There's some drawbacks to using ECS, like to empty the pool out to like refresh all the builders if they haven't run a job, we zero out the pool overnight. But that wouldn't really work for general compute stuff like we use Azure for, because there's no builders available and it would cancel all the long-running jobs, like if something runs overnight. So Sai uses Kubernetes to do like blue-green deployments and like more intelligent provisioning and management.
That's okay. That makes sense. And so if I understand the way you're describing it earlier is for you have this fleet of containers here, fleet of services that you're using. And I was surprised to hear, although I think it makes sense, but I want to make sure I heard this right, which is you're saying, look, we build them and then they sit there kind of idly waiting. And then when someone needs one, they execute against it and then we trash it afterward and then another one gets built. Right. So it's not like the container it's not a case of like, I need to deploy something so it builds the container on the fly and then executes my whatever. It's the container is part of a pool that's good to go, but it's used once, and once it gets used, it gets destroyed.
True. And it is possible to use that first model. I think that's the natural evolution here. That right now they just sit and they do nothing and they cost us money. And we scale down overnight, but we don't scale to zero. And it's not provisioned dynamically. We can do a webhook from like a hosted compute that's into code build in AWS, and it would spin up a builder and register and then receive the job that's queued and then run the job and then die. So we could certainly make it dynamic provisioning. It's just not there yet.
Yeah, I don't necessarily think that's, I mean, I think the model that you have is pretty interesting because it's obviously faster that way to do it. I just thought it was kind of clever. All right, I probably have more questions, but I'll let you talk and I'll interrupt later.
Bring it on. Okay, I'll do this part quickly. The rest of the build process is just in its automation. So we have a schedule. You can see this is actually cron. I don't know if Jordan's on here. He's probably the only one that could read cron without Googling it, but I Googled it. So overnight at 11 p.m. Pacific, we have this automatically run. And that's true of all of these. So overnight, it rebuilds from scratch the builder image and patches it and installs all the newest versions of everything. And we already had an instance yesterday morning, I think, where like 6 hours after I had manually run one of these builds, it had like 35 vulnerabilities because it could scan when we put it in ECR. And then it ran overnight automatically and there was 34 the next day. So like entirely through automation with like I was feet kicked up asleep, it patched a vulnerability and deployed it to all of the builders. So tons of automation, and we really just want to make patching a thing of the past in terms of our builder process. Cool. Okay, I'm going to transition to the running part, like how we actually run the thing. So if anyone has questions on the build part, let me know, but we are moving on. So over here, this is AWS, and I think it'll pull up if I type ECS. ECS is a portal. You can see a bunch of stuff, like here's our repositories where we're pushing our image into. So if I go here to ECR, one of these is the ADO builder, Ubuntu 20.04. And if we look into it, we'll see a new build each night, and probably also a couple more when we're making manual changes. But now we're down to 16 medium, 61 others. You can see it's sort of decreasing as time goes on, which is kind of cool. Just as things get patched automatically, and it pushes a new version here. So this was pushed at 10:40 this morning. But that doesn't run, like we built an image. That's the only thing that we've done so far. So we need to run it. You can either use Kubernetes, which is the Lamborghini. It does everything. It's just a little more complicated to run, or something like ECS that's very simple. So we have a list of things here. One of them is, these are all the CloudFormation deployed ones. They get these random things at the end. You can see the Terraform ones because they're a little easier to read. So here's the Azure DevOps cluster. And you can see we're using Fargate, which means Amazon provides the compute on the back end. So I don't have to provision EC2 hosts and then register them to ECS or EKS. I could, but I don't need to, and so I don't. So Fargate is spun up by Amazon, by this service, and it assigns containers to them that actually run and provide the compute power and memory and stuff, and they run. And you can see I have desired task 3 and running task 3. And if I go into here, I can see all of the tasks that are currently running. And they're just assigned this random thing. And I can say these specific ones, I can even just kill them and they'll come back right away. Let me see if I can go into one of these and just kill it. Yeah, let's just stop it. So this is a random builder. If a job was assigned to it, it would be interrupted, but I probably not, just statistically. And this will take a minute, and it'll notice that a container has been stopped. You can see we have 2 spun up, and our target is 3. So if I go back to services, you can see desired is 3, running is 2. And in a minute, I won't hang around for this whole thing. There we go. It's provisioning, because it noticed the builder died, which is totally a normal process, because every time a job is complete, the builder dies right away. So it can't take another job. So this is very common that these are constantly dying and being rebuilt by this service. We have a couple of other secrets manager things, but the gist of it, the bottom line is everything is stored in Titanium in one single AWS account, like the ECR image, the actual Docker image that we built. The secret, which is the pre-shared key that says I'm allowed to register as a builder and receive jobs and download secure stuff. And also the KMS key that encrypts the secret, because the secrets stored in KMS are either encrypted with a KMS, which is provided by Amazon, or a CMK, which is just ours. We're the only ones, and they're not able to read it. Given that this is somewhat sensitive, I decided to encrypt it on our side. So all of the other accounts also have their own ECS pools. I think we have 12 other accounts that are running these builders. And the cool part next that I wanted to show is just the Terraform bit, because I think it's kind of neat. As you can imagine, building ECS and logging and IAM policies for execution to get to the secret and get to the image and get to the CMK, the KMS piece, and also do maintenance and also do scheduling. There's a lot there, and it would be a pain if we had to go and build it in every environment. So rather than that, I built a bespoke module for these. And if I go into ECS, we can find our builders. That's GitHub. These are our builders. That's it. I'll zoom in a little bit. This is the only information we have to provide to it. What's your region? What's your account? What's the pool that you're going to try and register to? And what subnets and security groups to use for these hosts that are spun up. Absolutely everything else, which I'll pull up in another tab for all of the resources that are built, is just assumed. It's just automatic, because all of these look really similar, right? They're almost the exact same each time. So here, I'm just going to start scrolling, but you can see like there's CloudWatch, there's an IAM role that's used for this. Scroll, 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 scroll. This is several hundred lines of configuration that's bespoke for each environment, and it's built with 17 lines of module call. So just as simplified as possible. So it's really easy to deploy exactly the same thing everywhere. I think I covered everything. Did I miss anything, Sai? Or if anyone has questions, please chime in.
I think we covered everything. We didn't go to the AKS part some other time, but
totally. And that was kind of intentional. So this is very much focused on AWS, both because of time limitations and because that's the only part I really understand well. So I think Sai will probably do one of these in the future where we'll talk about a similar thing where we're building Docker, but we're deploying it on Azure with AKS. And that totally goes over my head. So I'm looking forward to that too.
And the biggest challenge we had there was running Windows on containers and AKS. So
totally. Windows it takes like an hour plus to build Windows Docker images and get them deployed. But we wanted to do it with the intention that this is a service we're going to provide to Viridime app teams and clients, whomever. If you need Windows builders, if you need your own Linux builders, and you have a Docker file, or even if you don't, we can help you. We would love to have you sort of pulled into our platform where we do the work for you and we host the things for you. Because it's going to help all of us, I think, to just keep things sort of standardized and patched. So like in security and operations, I think there's a benefit for everybody. Hopefully y'all agree, but if not, let me know.
Tyler, before we break, can you explain the nesting doll issue here?
Yeah, absolutely. That's something we didn't expect. So we need to build these images, right? But the whole point of this process was to move all of our builders to be run on Docker. Unfortunately, Docker can't build Docker because the Docker service won't start if it's not running in sort of a privileged mode, which is not supported or allowed by Fargate on AWS, or I think AKS also does not really let you. Yeah. So this is a longstanding issue. We're by far not the first people to see it. So the way that we're doing this now is we're using public builders to build our stuff and push them into AKS using secure credentials that are very limited in scope. So they can't do additional stuff, even if they were to leak. And Sai actually did some research and found that GitHub itself, to run their hosted builders, is using Packer. Probably for this reason. There might be others, but certainly this one is a big one. People want to build Docker on their stuff.
And one of the reasons why we didn't move our DevOps agents off machines yet, because of this dependency. We still have VMs running jobs on Azure DevOps.
We would love to bring them in-house because then we get the advantage of like caching. If you've ever built a Docker image twice, the second one is like 1/100th of the time normally because it uses the cache for each layer, each command. So because we're using public, it does every layer each time, which is just quite a bit slower. But we need to solve that problem. Like maybe we have bespoke Docker builders that are built with Packer or auto-scaled or something. It's something Sai and I haven't solved yet. We will at some point.